Let's write sine to the fourth of 3x in terms of the first power of cosine. We're going to need our power reducing identities, which are written over here to the right, and they involve sine squared and cosine squared. So if we're going to get this sine to the fourth to be a first power of cosine, we're going to start by rewriting sine to the fourth of 3x as sine squared of 3x all squared. And now, sine squared of 3x, we can look to our power reducing formula, and in the place of theta, we have our 3x. So when we apply our formula here, we're going to have in this set of parentheses 1 minus cosine of 2 times 3x, and then all over 2 squared. So now we have applied one of the power reducing identities, and then let's take a look at what we have here. So I have a quotient that's being raised to the second power. So what I'm going to choose to do is I'm going to rewrite the numerator 1 minus cosine of 6x all squared, and then the denominator is 2 squared, which is 4. So basically, I'm going to go ahead and keep the 1/4, because of course there's a 1 in front over here. I'm going to keep the 1/4 kind of in the front, because now what my job is next to do is to expand out 1 minus cosine 6x, that entire quantity, squared. So it's 1 minus cosine 6x times the quantity 1 minus cosine 6x. So I'm going to distribute. I'm going to have that 1/4 in front, and then I'm going to have here 1 times 1 is 1. Outer and inner is going to be 2 copies of negative cosine 6x, so minus 2 cosine of 6x. And then these last two, negative cosine 6x times negative cosine 6x, is plus cosine squared of 6x. So far, we have gone from a sine function raised to the fourth power down to this expression that is all in terms of cosine now, but not cosine to the first power. We still have a cosine squared involved. So what we're going to do is apply the other power reducing identity that we haven't used yet, the one that involves cosine squared. And in the place of theta is going to be 6x. So the rest of the terms are going to stay the same. So I'm going to have 1/4, all these other pieces, times the quantity 1 minus 2 cosine of 6x, and then plus, now this is going to become 1 plus cosine of 2 times 6x all over 2. So we replaced our theta in the formula with a 6x this time. Okay, so now we do have an expression that's entirely in terms of cosine raised to the first power. We just want to do a little bit of cleaning up on this, a little bit of simplifying what we have going on here. So what I'm going to do is I'm going to split this up as 1 over 2 plus 1/2 cosine of 12x, and I'm going to move my work up here. So I have 1/4, 1 minus 2 cosine of 6x, then plus 1/2 plus 1/2 cosine of 12x. And so this 1/4 is going to distribute to all of the terms inside these brackets. So here inside the brackets I have like terms. 1 plus 1/2, that's 3/2. So this and this right here, that becomes 3/2. So when we multiply 1/4 times 3/2, that's 3/8. So I'm going to have 3/8. When I multiply 1/4 times negative 2 times cosine of 6x, that's going to be negative 1/2 cosine of 6x. So just simplifying 1/4 times 2. And then this 1/4 is going to apply to the 1/2 cosine 12x. So 1/4 times 1/2 is 1/8. So plus 1/8 cosine of 12x. So now this is simplified, and you might be wondering, well, this is a lot smaller, right? Sine to the 4th of 3x. Why would I want to expand it to something that looks like this? Well, it turns out that this operation that we do in calculus called integration is a lot simpler on these three separate terms where cosine is only raised to the first power than this nice small single term, but that's raised to the 4th power.